I need to have posters, what I need. All right. I want you to graph f of x, and this is 4.1 and 4.2. It's kind of all together. So f of x is equal to negative x squared plus 2. Now I want you to either graph it by hand, use complete and square, or do it on a calculator. I don't care. And I want you to label, let's remember that we're in 109 or Math 110, and I want you to label everything about the graph after you sketch it. Sketch it in your notes after you put it on your graph. Sketch it, and I want you to do increasing, decreasing, domain, range, vertex, all that good stuff. I'm going to go through and do, I'm going to do complete and square. And this is just kind of a review over what to find plus 2. So that's going to be negative x squared plus 0x plus 2 is equal to 0. Negative x squared plus 0x plus blank, negative 2 plus blank, negative 1, x squared minus 0x plus blank is equal to negative 2 plus negative 1 times blank. Half of 0, 0, 0, 0, that goes out. Negative 1, x minus 0, quantity squared is equal to negative 2. So our vertex is 0 and 2. Vertex is 0, 2. My y-intercept is what? 2, Hubert. And let's find our x-intercepts. Negative 1, x minus 0, quantity squared is equal to negative 2. Divide by negative 1, divide by negative 1. X minus 0, quantity squared is equal to what? 2, 0, x is equal to positive and negative 1.41. Okay. So I want you to graph everything on that graph, the x-intercepts, the y-intercepts. Tell me what's increasing, tell me what's decreasing, and, you know, what else? And if you can't do that, then that means pretty much that you're going to fail this last test.
Awesome.
You're welcome. Go ahead and make sure you write everything down because I'm going to go to a new screen here in just a minute. All right, I'm just going to make this small so I can still see it. All right, so we've got a graph, and it looks like our vertex is 0, 2, and our y-intercept is 0, 2, so that's the same point. We know that it's open in which way?
Down.
Down, and 1.41 and 1.41. So it looks like that. And everybody feels good about themselves? Now, this point right here, what is that called? Well, it's called several things. It's called the vertex, and it's also called, in this case, the y-intercept. But we're going to focus on the vertex. The vertex, what is always true about the vertex? It's always what? It's always your highest or what?
Lowest.
Highest or lowest on a parabola point. Okay, and as you said, what did you say?
Max or min.
It's always your max or min. Now both of these sections are on max and min. Relative, local, absolute. Okay? Absolute, we'll get into that in 4.2. But this case is the max because you've got an upside down bowl. Okay? So that means you've got a highest point. All right? So we've got a max here, relative max. What does relative mean? Relative means that it pertains to the function. Okay? Where absolute means the highest point, period. Okay? This is the highest point, and it's also the max, which means that it's the relative max. Now, at this point, what can you say about the tangent line at the vertex? The tangent line is always going to be what? Starts with an H. Horizontal. If the tangent line is always horizontal at the vertex, what is M? Slope is always going to be 0. And remember that, because in a few minutes we're going to set something equal to 0, and that's why. And for other reasons. Okay, so 4.1, I think that's what I said, right? 4.1. 4.2 and 4.3. Sorry, that's supposed to be 4.2 and 4.3. 4.2 is on finding the relative max, finding the vertex. So that's not very difficult. Between completing the square and your calculator, you should all be able to do that. Now, what's another way? That's how you find it. This is one way to find it algebraically. This is the way to find it graphically. So what's left? What class are we in? Calculus. So in calculus, we use the dang old what? First derivative. So take the derivative of negative x squared plus 2.
What did you say?
Take the derivative of the function negative x squared plus 2. So f of x is equal to negative x squared plus 2. Therefore, f prime of x is equal to negative 2x. Now somebody tell me what that is, and don't say it's a derivative because I know it's a derivative. What is it? I told you this.
Slope.
It's calculus. It's the equation for the what? Slope of the tangent line. Write that down if you don't remember it, which none of you do because you would have said that. Okay? It is the equation for the slope of the tangent line. Now, one of the reasons I picked such a simple question algebraically is kind of go over a review, but also so you can understand where I get the next part of this. Okay? What is our main objective in 4.2? Our main objective is to find the max slash min, or in this case, the what? The vertex. Okay? That's your objective in 4. Or a good part of 4.2 and 4.3. So let me ask you a question. Let's say that I have no idea algebraically, and I have no idea graphically. That's not on the board right now. I just got negative x squared plus 2. If I take the first derivative, what am I going to set that derivative equal to find the vertex? 0, because the tangent line at the vertex is always what? M is equal to what?
0.
If the slope of the tangent line, if the equation of the slope of the tangent line is negative 2x, and you know that the tangent line at the vertex is always 0, then I'm going to set negative 2x equal to what? 0. So let's do that. And you get x is equal to 0. What do you do there? Well, you know at that point that the point at x is equal to 0 is your max or min. I'll get to that in just a minute. We're going to go over to the next page. Max or min. Okay? How do you find out well, you plug in 0 here. What do you get? 0 squared plus 2 is what? 2. So we know the vertex without looking at algebra or looking at complete the square or looking at the calculator. Using the first derivative, negative 2x is equal to 0. We get 0, 2. And we know that the vertex is at 0, 2 without even graphing, without even doing it algebraically, by just using the first what? Derivative. So let's look at that. So we know that this point right here, we know that the line is like that. We know that this graph is like this. And we know that M is equal to 0. Therefore, f of x is equal to negative x squared plus 2. F prime of x is equal to negative 2x. So we're going to take these two and set them equal to each other. Negative 2x is equal to 0. X is equal to 0. Plug back in f of 0. F of 0 is equal to 2. 0, 2 is our vertex. Now take a number line. And the number line is in terms of x. So we're going to put a 0 here. And I'm going to put a negative 1 right here. You don't have to put a negative 1. And I'm going to put a 1 right here. Okay? We know that 0 is pretty much the teeter-totter. That's where the vertex is, right? Right here. So I'm going to plug in negative 1 into my first derivative. What's negative 1? So I'm going to go down. F of f prime of negative 1 is equal to what? What's negative 1 times negative 2?
2.
Okay, positive 2, right? So I'm going to put a positive 2 right here, and I'm going to circle that positive. So that means that everything to the left of 0 is what? So we know that our value is increasing. Now remember, we don't know what it looks like because we're just using derivative here. We don't even have a graphing calculator. Okay? Because on the next one, we're going to not use the calculator. Okay, now what goes up must what?
Down.
Come down. But we're going to check it. We're going to take our handy-dandy magenta, and we're going to plug in f of 1. What's 1 times negative 2? F prime of 1. Negative 2. So that negative means that this side is what? Decreasing. So I've got a question to ask you. And if I can spell decreasing, there we go. If I have increasing coming up this way, and then I hit the critical point, and then I go down, that means that this is not a minimum, but it's a what? Maximum. All this you should be able to get from taking the first derivative. And you're going to be taking the second derivative too, but that's later. Which the second derivative of negative 2x is what? Negative 2. Dang old collection point. All right. Who's got a question? I told you this was going to be easy. This is nothing, that 4.1, 4.2 and 4.3 is nothing but this. Algebra, calculus, and calculator. Okay? If you can do those three things, you should be able to do 4.2 and 4.3. If you're able to work your calculator, graph on your calculator, trace on your calculator, find the intercept, find the y-intercept, whatever the case may be. X-intercept, sorry. If you can find all that, and you can do the algebra, and you can do the calculus, taking the first derivative, then you're good. So, with that being said, I want you not to use a calculator, not to use algebra, but just use the first derivative, what I just showed you, and do f of x is equal to x squared plus 3x plus 7. Take the first derivative. If you want to, find the x and y of the vertex. So I'm calling it a vertex because I don't know if it's a, well, you know it's open and upward, so is it going to be a max or min?
Yeah.
Min, because it's open and upward. You know that because you know your algebra, and that positive in front of that x squared tells you that it's going to be a min because it's open and upward. Well, at least I know the Easley campus, except for 2 people, check their emails. Except for 2 people. But I'm glad to have you in class, both of y'all. And Ms. Shuttleworth finally coming to class helped also.
Did you get my text?
The Anderson campus, I mean, the Pendleton campus would be lost without you. It took them 15 minutes to figure out how to use the Skype, so if you die tomorrow, at least you know you're valuable to the Pendleton campus. Calculus class.
That's reassuring.
If you get hit by a bus, Oh, come on, what's the odds? She's going to get hit by a bus, okay? I don't know.
Walking back to my car, the Clemson bus run me over.
Actually, dang old bird box, dang old sister, dang old walk down the truck, dang old boom! Dang old, she went all over the place. Okay. All right, so f prime of x is equal to 2x plus what? So the first thing I'm going to do is I'm going to set 2x plus 3 equal to 0. And minus 3, 2x is equal to negative 3, x is equal to negative what? Okay, so at negative 3 halves, we know that we have part of the vertex. So let's go ahead and find, plug negative 3 halves into your original equation. So I'm going to go up here and I'm going to say f of negative 3 halves. And of course we can't do this. Why? It's a fraction and we can't do fractions. So we might as well just what? There you go. Music to my ears. Just quit. Want to start a revolution, but you can't even start a lawnmower. All right. Y'all seen these people on TV? These snowflakes. They got yellow hair and purple hair and got pierced cheeks. Y'all seen the pierced cheeks, right? Where they got holes in their cheeks. Y'all seen that? Gauged cheeks. Yeah. They can't even start a lawnmower, and they're gonna start a revolution.
You said that.
I have a question.
I'm not on the clock right now. What?
So for the one before this, we plugged 0 into the first derivative equation, but now we're setting it equal to 0?
No,
Is
you
that
always
like
set
a-
it equal first.
Oh.
Okay. You set it equal to 0. Because what is the slope of the vertex? Of the line at the vertex? It's horizontal,
0.
right?
Yeah.
So it's 0. So you're setting the slope equal to 0. You always set it equal to 0. Okay? Now right now, I'm trying to find where the y value is at x is equal to negative 3 halves. So I'm trying to find my y of my vertex.
Okay.
That's what I'm trying to find.
Gotcha.
In a minute, we're going to put it on the number line, and that's where you can see where it's increasing and decreasing. Okay, so that's what I'm trying to find right now. So, since we can't do this, I guess we'll have to rely on the calculator since we can't do it, but I'm not going to. That's going to be 9/4. What happens to the 3's right here? Well, 3 times 3 is what? Negative 9. So that's going to be negative 9 over what? Negative 9 over 2, which is negative 18 over what? 4.
And then that's 7. It's supposed to be 7 plus 7. Right?
On the very
On the
end.
very end.
You have negative 3 over 2. Unless you.
Oh, I'm sorry. Thank you. Which 7 is 28
I was
over
about
what?
to say that.
Be quiet, Miss Shuttleworth. You're high. Plus 7. Okay. So what's 7? 28 over what? 4. So what is 9 minus 18? Negative 9. And what is negative 9 minus 28?
Negative 37.
Negative 37 over 4. And that would be what? Negative 9 and 1/4? Somebody check me. 9.25. What is 37 divided by 4? Okay, so our vertex, I can't write it anywhere. Our vertex is at negative 1.5 and negative what? Negative what? 9 point.
I think that's a positive.
It's
What's a positive?
Wait, it has but
28
it's
over
minus.
4.
Oh, that's supposed to be a plus. I suck. So 9/4 minus 18/4 is negative 9 plus 20. 21/4 or 19/4. What is it? That was my bad. I put a negative.
19.
Is it 19/4? And what's 19/4? They go 4 3/4.
Yes, sir.
All right. So here's our vertex. Now again, we don't know anything because we don't know what it looks like. Now, of course, some of y'all might know what it looks like, and that's good. That's a good thing. But let's say we don't. So let's draw our number line.
He added it.
And what's the x on our number line? What do we say x was? Right here.
Negative 3.
Negative 3 halves. Negative 1.5 or negative 3 halves. Whichever one you want to call it. So what's below negative 1/2?
Negative 2.
And what's above 1/2? What am I going to use? Why am I going to use 0? Because if you can't multiply something by 0, you don't need to be in calculus. All right, so where are we going to put it? Okay, well, you're going to plug this back into the first derivative right here. All right, so what is negative 2 times positive 2? And what's negative 4 plus 3? So it's negative, right? So this side is going to be negative. Now somebody plug in 0 times 2. 0 plus 3 is... So what do we got? A max or a min? Which way do we read? Left to right. So what do we got? A min. So this is not a vertex now. It is a what? Min. So now I want everybody to use completing the square or your calculator and graph x squared plus 3x plus 7 and check to see if you got all the same stuff I've got. Oh my Lord. In the Anderson Independent.
For what?
Former student at Tri-County, dang old teacher, dang old advertising for Tri-County. Posters, using posters in class.
People, do you know, like, why if I, like, hit y equals and then it just doesn't pop up on my graph? I mean, I know I'm on a team, I'm practicing.
What is this, T84? Probably because you got the stat plot on, that's why. Turn the stat plot off. And now, when you hit y is equal, God, I'm amazing. There you go.
Thanks, Coach.
There. So, what do you get? Somebody tell me what the vertex is. Well, let's say you don't know how. And I guarantee you somebody didn't pay attention when we went over this in Unit 1. But we'll go ahead and try it again. Let's take our handy-dandy calculator and type in y is equal to x squared plus 3x. I should have a teaching assistant doing this.
You need a TA?
Yeah, for free, because Tri-County ain't gonna pay them. Plus 3x plus 7. And dang old hit the graph key. And there it is. And we said that it was going to be decreasing on the left and increasing on the right. So all we got to do is find the vertex. So what do we hit? We hit second, trace, dang old min. And I'm going to give it a left-hand side. That just helps it calculate. You don't have to do this, but just narrows down the search. And then gives us, there we go. Negative 1.5, comma 4.75. Look there. Isn't it a miracle? Therefore, you don't have to wear sunglasses inside. I went into Target the other day. I don't go in very often because I have to go to town, and I don't go to town very much. And Amazon's my best friend. And there's a homeboy in there with sunglasses on. I laughed at him. I think it hurt his feelings. Idiot. And he had the Harley Davidson look on his face. You know what that is, don't you? That's when you can't smile, you have to look mean. I know what I'm talking about. Like I said, girls, see guys, run. Run like hell. Don't run away fast as you can. All right, let's do a nerd. Let's do a cubic function so you can quit. Let's do x cubed, f of x is equal to x cubed plus 3x squared plus 4x minus 2. Might as well quit on this one. Now we're not going to use complete the square on this one because actually you would have to use long division and find the roots, and I'm not going into that because that's why you have a calculator. So we're going to take the derivative. F prime of x is equal to 2x squared plus 6x plus what? Now we're going to use what? We got to set equal to 0, so we're going to have to use the reverse FOIL or completing the what?
I think it's 3x.
What?
I think it's 3x.
Oh, it is?
3x squared.
Oh, thank you. Okay, so I'm going to use completing the square because I like to challenge myself and raise the bar and not just settle for minimum wage. 4 is equal to 0. No, we need to raise our minimum wage to $15 an hour.
Target's raising theirs to 13.
Therefore, everybody, we can lower the bar and make a full-time job out of a part-time job. The heck with raising the bar. Y'all don't want to raise the bar, do you? Nobody's going to say anything because they have no idea what I'm talking about. Keep them dumb. Keep them stupid. Easier to control.
When you said that about the revolution the other day in class,
Uh-huh.
somebody before me said, you don't need to actually start a lawnmower to start a revolution.
When did I say that?
Said it was one day last week in Matthew.
They didn't even understand what the hell I was saying.
Probably not.
Yeah, because if you can't start a lawnmower, that means you don't have the critical thinking to start a revolution. You don't even know how to work a damn gun. Oh, I'm sorry. Did I say gun? Did that offend anybody? 3x squared plus 6x plus blank is equal to negative 4 plus blank. Factor out of 3, x squared plus 2x plus blank is equal to -4 plus 3 times blank. Half of 2 is what?
1.
1 squared, put that in your calculator, you might need to figure that. 3 times x squared plus what? I'm sorry, x plus 1. Quantity squared is equal to what? -4 plus 3 is -1. So our vertex is 1 and what? 1. -1 and 1. So write that down. Vertex is -1 and what? +1. So you know your x value, okay? So we got 2 x values, so we need to figure out what's going on. That's the vertex. So let's go ahead and figure, it's probably going to turn, let's go ahead and figure at -1. Yeah, that's going to be our, -1. So what's above -1? 0, and what's below -1? -2. So what happens at -2? Let's plug in -2 and find out. -2 squared is what?
4.
+4. That's 12. Put a 12 right there. What's -2 times 6? -12. And then plus 4, what's 0 plus 4? 4. So we got a positive there. And then 0. What happens when you plug in 0? You get 4, so that's positive. We also going to have to find our X-intercepts. Somebody find your X-intercepts, because we got something going on here we need to figure out, because it looks like to me we got something that's continuing, and we got to find where it's turning. So we know it's turning at 2 places. So 3 minus 2 is equal, I'm sorry, 3 minus 1 is equal to 2. We know it has 2 turns. Okay, so let's go ahead and solve it. And it's not crossing the x-axis, so that's probably why. So let's go ahead and look at the graph. And we plug it in. We get y is equal to x cubed, so we put an x cubed right there. And then plus 3x squared. 3x insert squared, right, insert squared plus 4x minus 2, 4x minus 2, and graph. YB, look at there. What's it doing? It's always what?
Increasing.
Increasing. And your vertex, let's blow it up a little bit. Zoom. Let me see about zoom fit. Let's see if zoom fit will work. Where is zoom fit? 0? Let's see if that makes it better. Yeah, there we go. So let's look and find the vertex. The vertex is going to be right in here, so I'm going to do second, calculate, and it's going to be a vertex because it's not a min or a max. So I'm just going to put, no, not intersect, I'll just do minimum. And I'm going to put a value right in there, and a value right in there. I have no idea what we're going to get. Guess maybe I need to blow it up. It may have hidden value. I think it has hidden values. So let me go in a little bit more. Zoom, box, and I'm going to go in and I'm going to zoom in between there. And again, like I say, you need to learn how to use your calculator. Yeah, it looks like it's right in here. So it looks like the vertex is going to be -1, +1. You're going to have to blow it up even more because the y is 12 right here, so you're going to have to blow it up even more than that. Zoom in. I'm just going to zoom in and see if we can't keep finding it. Zoom in. There we go. And it looks like to me I've got my signs a little bit backwards, I think. I may have a sign. Or if I got my, let me check and make sure I got it in there right. X cubed plus 3x squared plus 4x minus 2. Yep, I got it in there. But why is my vertex not right? Something's not right. Anybody? Let's see what this point is. Trace. Let's go to -1. X is equal to -1. There's well, that's -0.1. So let's see at negative. You can do the window also. I'm just going to find one. The scale on this thing is way, yeah, I'm not getting the right answer. So I've got something wrong or the graph is not right, one of the two. But we do have the vertex, but we've got it increasing and increasing. I don't know what I've gotten wrong unless somebody can find out where I've made an error. I don't see where I've made an error. Anybody got me? My vertex is not right. Factor out of 3. 6 divided by 3 is 2. Half of 2 is 1. 1 squared is 1. So I don't know what I've done. I've done something wrong. I don't know what, but not everybody jump at one time. Zoom.
Is that 3 at the bottom just like go, like, is it not -1/3?
Divided by 3. There it is. Thank you. Well, that's when you solve. You get -1/3, and that means that you got no x-intercepts. Well, that can't be right because you do have an x-intercept. See, I've got something wrong somewhere. Because when you divide by 3, you take the square root of negative. Yeah, there's something wrong. I've got something wrong somewhere. And nobody's going to help me find it, so I guess I'll just... No, that's... Okay, no. That's not... This is not finding the x-intercepts. You can't find the x-intercepts with the derivative. The x-intercepts would come up here. You can't find the x-intercepts right here. You're only finding the vertex. So that's what I've got at -1. Plug -1 back in here. Let me see if that's right. Plug -1, that may be where I'm going wrong. Plug -1 back up in here. -1, -1, -1. -1 cubed is what? -1. -1 squared is 1 times 3 is +3. And -4, yeah, I bet that's it. -2, that's what I did. I just combined, I know what I did. -1 plus 3 is what? 2. 2 minus 4 is what? -2 minus 2, that's better. -4. That's my fault. -4. That looks better. All right, that's not the vertex. That's where it turns. That's in which we're going to get into in 4.2. Okay, or 4.3 when you get the turns. So let's look at one that's in the homework. We only got a few in the homework to do. So let me go to the handy dandy homework. And there's your first one. Okay, go ahead and I want you to graph it. I want you to do complete the square, whatever you want to. I would change that 1.5 into what? 3/2? That's the first thing I would do. Okay? And go ahead and find the derivative and set it equal to 0. So go ahead and do that. I'll get the handy dandy whiteboard pulled up. Now, honestly, you know it's going to be a what? A min or a max? It's going to be a min because which way is it opening? It's opening upward because you know your outward. And all that ties in. If you notice that from the get-go, that's a good thing. So what is the derivative of x squared?
2x.
2x. And what is the derivative of 1.5x?
1.5.
So that's your derivative. Okay? Now set that equal to 0. 0 is equal to 2x plus 1.5. Minus 1.5, well, minus 3/2 is equal to 2x. Divide by 2. Divide by 2 over 1. When you divide by fraction, you multiply by the what? So negative 3/4. Now, plug the negative 3/4 into your original equation to find the y. So f of negative 3/4 is equal to negative 3/4 parentheses, squared, plus 3/2 times 3/4 minus 4. Minus 4 over 1. And that's going to be 9 what? 9/16 plus what? Plus 9 over what? 8. Which would that be? 18 over 16? Minus, what's 16 times 4? 64. And what's 9 plus 18? 27 minus 64 over 16. And 27 minus 64, dang old 14, dang old 7.
37.
What?
37.
37 being negative 37 over 16. So our vertex or our max or min is going to be at negative 3/4, negative 0.75, comma, 16 will go in there twice, that'll be 32, right? So 2 and 5/16, I think. Negative 2 and 5/16, which 2 and 5/16 is like 2.333. And I've got it wrong, haven't I? I've got 0.75 right. Check my math. I think I've done something wrong on the math. Let's see. What's 3?
0.3125.
Where? What?
It's 2.312537.
Yeah, but they've got negative 4.5625, so I've done something wrong. So check my math up there. Maybe I've done one of the facts. Plug in 0.75 into that function, and you should be able to get it. Evidently I've done some math wrong somewhere. Somebody do it. Plug in 0.75 into the original and tell me if you get negative 4.5625, or they might have an error. I don't know.
Yeah, I just got that by plugging negative 0.75 in.
Okay, so let me see where I've got mine wrong. All right, negative 3 times negative 3 is 9. 4 times 4 is 16. 3 times 3 is what? 9 over 8. So let me go back here and put 9 over 8. 8 will go into 16. 2 times 9 is what? 18. And then 1 will go into 16 how many times? 16 times 4. What's 16 times 4? 6 times 4 is 24. Bring you 2. Okay, so I must have done something wrong here. 9 plus 18 is 27. What's 27 minus 64?
Negative 37.
Okay, I don't know what I've gotten wrong. I don't understand. I don't know what I've gotten wrong. And you said you plugged in 0.75, negative 0.75, and you got 4.56?
Is it because you multiplied 3 over 2 times positive 3 over 4, or would that not make a difference?
Thank you. Thank you. I suck. Whole class didn't even see it. Okay, so that's going to be negative. Thank you. That's going to be negative right here, wouldn't it? So that's going to be 9 minus 18 is negative what? Negative 9. Negative 9 minus 64 is negative what? 73?
Yes, sir.
Yes.
Oh, we just transposed our numbers, that's all.
Oh, yeah.
That's what we did. We just transposed our numbers. We didn't do any wrong math. We suck. 73 divided by 16. Somebody tell me what that is.
4.56.
There we go. Now we cooking with peanut oil. Negative 4.5 something. Okay, so let's write down what we're doing. First thing we do, we find the what? Find the derivative. So write that down. First, find the derivative. Second, set the derivative equal to what? Why do we set the derivative equal to 0? Because the derivative is the equation of the slope of the what? Tangent line. And what is 0? The slope of a horizontal line at the vertex, right? So that's why you're putting those two together. Once you get the x, this is the product of the second part. What do? You plug x back into the original what? Equation. And make sure you do the math right, not do like the teacher and just make up numbers, okay? Make sure you plug in the negative 3/4. And that will give you the x and y coordinate of the what? Of the max or the min. Until you know what it is the vertex. But then, after you do, and of course you would write out, right here, you would say, and this is number 5, if my test is going to ask it, I don't know what the homework is going to ask. So I'm going to put what? What's my x? Negative 0.75. So of course, what's this number going to be? 0. What's this one going to be? Negative 1. So somebody plug in negative 1 into your derivative. Negative 1 times 2 is negative 2, right? What's negative 2 plus 1.5? Positive or negative?
Negative.
Negative. So this one is decreasing. What's 0? 0 times 2 is 0 plus 1.5. Is that going to be positive or negative?
Positive.
So what is this function doing? From left to right, it's what? Decreasing and increasing. So it's opening upward. So at that point, you know this is not a max, but a what? Min. And that's what they're wanting you to be able to do. Not look at a graph and use the first derivative to do those 5 things. I guess that would be 5 right here. Number 5 would be to think about it from left to right. Okay, there. Number 5 right here. Here we go. Think about it from left to right and what's it doing right here. And then determine that your vertex is not a vertex now, it is a minimum. Because not all the times are you going to be given the function, or not the function. You're not going to be given the graph, or you're not going to ask the graph. They're going to ask you just to find the vertex and using the derivative. Dang old beautiful mind, dang old drawing all them lines, dang old taking the first and second derivative. Dang old beautiful mind, y'all know what I'm talking about?
Yes, sir.
It's a movie. For those of you that don't know. I asked my class this morning, they ever watch Caddyshack? Don't even say nothing. I don't want, it made me mad, so don't even say nothing. If you ain't watched Caddyshack, you should. All right. We had one person. What's a Caddyshack?
That's
It's what used to be around before golf carts. All right. What's a golf cart? Do this problem and don't ask questions. Number 2. Let's see what time it is before y'all start convulsing. Okay, we're good. Go ahead and do number 2. I'll do 2 problems of your homework. X cubed minus 6x squared minus 2x. X cubed minus 6x squared minus 2x. Now in this case, you might not be able to do some of the stuff that you were doing with the parabola, okay? Because this thing is turning 2 times, got 2 turns in it, and it's going to be a cubic function, which means the ending behavior is going to look like this. Everybody with me? So you know it's going to be doing something funky in the middle, or it's going to be just a 1 increasing, okay? So let's see what happens. H prime of x is equal to 3x squared minus 12x minus 2. Y'all check me and make sure I didn't make a mistake again. So that's 3x squared minus 12x minus 2. Now set that equal to 0. And solve it. So I'm going down here and I'm going to do 3x squared minus 12x plus blank is equal to 2 plus blank. Factor out a 3. And that's going to give you x squared minus 4x plus blank is equal to 2 plus 3 times blank. The X-Intercepts is what you want on this, not the vertex on this one, okay? Because you're taking the vertex. That's where I made a mistake a while ago. You want the vertex of the function. So this is the vertex of this part. The derivative is not what you want. So half of 4 is what? 2. 2 squared is 4. So that's going to give you 3 times x squared minus, I'm sorry, I did it again. X minus 2 quantity squared is equal to, what's 2 plus 12? Now, solve this for x, because that's what you need. That's your vertexes of the function. Solve them for x. So x minus 2 quantity squared is equal to 14/3. Let's go ahead and find what is 14 divided by 3. Dang old 4 2/3, which is 4.67. Somebody check. What's 14/3?
4.66666.
Okay. X minus 2 is equal to 4. Quantity squared is equal to 4.67. Take the square root of 4.67 for me, please. What's the square root of 4.67?
2.16.
2.16. 2.16 plus 2 is 4.16. So we've got a 4.16. 4.16 positive. Oh, I drew my arrow wrong. And then what is negative 2.16 plus 2? Negative 0.16, right? So that's our 2. So negative 0.16. Let me draw my arrow differently. (4.16) and negative 0.16. So you got a couple of terms. So what am I going to plug in below negative 0.16? Negative 1. What am I going to plug in here? 0. And what am I going to plug in here? 5. Plug that into what? Your derivative. So somebody plug in negative 1. Okay, negative 1 is going to make that positive 3. Minus negative 1, that's going to be a positive 12. 12 and 3 is 15. 15 minus 2, positive or negative? What? Okay, I'll plug in 0 for you. I get a negative. And then what? 5. Well, 5 squared, that's going to be a BA number. Then dang old 5 times negative is 75. Is that 75 minus 60? Is that going to be positive or negative? So if I've got a graph right here, I'm increasing from negative infinity. Let's put these x's right here. Negative 0.16 is right here. And 4.16 is right here. And 5 is right here. I'm exaggerating a little bit. But what is my function doing from negative infinity to 0.16? It's increasing. Then it's what?
Decreasing.
Decreasing. Then it's what? It's decreasing from negative 16. And then it's what?
Increasing.
So it's looking something like that. So somebody graph it. Tell me what you get. Tell me if it looks. I mean, mine's not going to be perfect, but it's going to look something like this. Now, I don't know what we haven't found the y's yet. So let's find the y's. Plug in negative 0.16. Plug that into this and plug in the 4.16. Plug that in there and see what you get. And that's where you get your where it turns. Okay, look here, y'all. There's what they did right here. So plug in negative 0.16 into your function. What you're doing when you plug it into the function, you're finding when you plug the x values into the function, f of x, you're basically getting the coordinates for the vertex or the min and the max. You're getting the actual. So what do you get when you plug in negative 0.16 into this function? Blurt it out when you get it. Eventually, y'all will get it. What'd you get?
Negative 0.0692. Oh, I feel like I did that wrong. Oh wait, yeah, I see where I
Such a disappointment.
Just mark me up as a failure.
Pendleton, yeah, easily. What'd you get? Lord, half of these in the class left. She left. Did you offend her?
I didn't say anything.
No, it doesn't matter. You don't have to say anything now. You probably offended because you're wearing a light-colored shirt.
She'll be back.
Oh, she will? I'll be back.
Her stuff is here.
Pendleton, what'd you come up with? Pendleton, they're asleep. They don't know what's going on.
.162.
Did you get .162? Okay, we got one person with a Duke shirt on. Okay, so she's smart. She got a Duke shirt on. Who won the, is it March Madness? Is it over yet?
Yeah, it finished last night. Virginia won.
Okay. Was that a big surprise or what?
Not really.
Okay. All right, so what do you get when you get 4.16? Plug that in. And let's look at the function. I'll pull up the handy dandy calculator.
Yeah, every time.
And let's plug in y is equal to. Oh, is this the no, this is a different function. Let me erase this because I can't see nothing. You know, life would be much better for y'all if I used posters, wouldn't it? Maybe that's what I should say that in that article they're going to put on. I use posters. All right, what is the function? X cubed minus, I don't like this, minus 6x squared minus 2x. Delete. Graph. Let's go ahead and do a zoom fit. So let's do zoom standard first and see what it looks like. Yeah, this is going all over the place. So let's do a zoom fit. There we go. We're cooking with peanut oil now. Oops, I said oil. I'm sorry. Somebody needs to say I didn't say it right. Do y'all even comprehend what's going on? Revolution! All right, so there they are. If you want to blow it up, then go in and blow it up. Zoom box. I don't know if it does make it any better, but we'll go ahead and zoom in maybe. You know you only need to carry x is equal to negative 0.16, so it's not like you're going to miss it. And what's our y? 4? I mean, our next one is 4. 1, 2, 3, 4. So there's that. And now you can see a little bit better. 1, 2, 3, 4. I need to, God, that's 16. So somewhere in here is changing. Okay? Question, gripe, complaint. All right, so what y'all need to do now is work on 4.1 and 4.2, and we'll work on 4.3, which is a continuation of this. Come, what's the next day y'all gonna be here? Thursday?